Okay, so hi everyone. My name's Cody. I'm from Texas. So I'm gonna be teaching you guys AP Physics 1. So I'm sharing the syllabus right now. Can everyone see my screen? You can just like type in the chat, or can everyone? Yeah, okay. Okay. So yeah. If you have questions or anything, or want me to like slow down or anything, y'all can just type in the chat. Um, so this is the syllabus. Today is the first meeting. We're going to be covering kinematics, and then yeah, so classes are like every week on Wednesdays and Saturdays, and they start at 6 p.m. Eastern time. Um, okay, so I guess we're gonna get started. So first of all, in physics, you need to know what vectors and scalars are. So basically, um, a lot of times with math, you really only talk about scalars because like it's only magnitude. It's like so like for like displacement and stuff like that, there's a direction. So like usually when we talk about speed, people like say, oh, I'm driving 50 miles per hour, right? That would be speed because there's no direction. You're talking about how fast you're going. There's only a magnitude. But then with vectors, it has a direction. So like say you're going 50 miles per hour north or 50 miles per hour south. So with vectors, there's magnitude and direction. So it's important on the AP test to know that. So then, for example, so for like a vector, a lot of times you can use arrows to draw a vector. So then like, for example, let's say this would be like vector A, right? So you use the arrow to show what direction it is, and then you can like add vectors. So then this is be vector B, right? So then if you wanted to add vector A, if you wanted to add vector A plus vector B, you would you take the tail end of one vector and then you put it at the point of another vector, right? And then you would draw it from one end to the other. So that'd be your final vector, right? So let's call it vector C. So like if there's an arrow above a letter, then that would indicate it's a vector. So then yeah, that's a vector. So then position. So position would be like where an object is. So like for example, like uh let's say we have like a number line, right? And then like so then like there's a person standing here, right? That's the position. So then when we talk about distance and how far things are, there's a difference between displacement and distance traveled. So like say this person goes from here and then they walk to point 3 and they walk back to their original position. So what that mean is the displacement is the change in position of the object. So like it's this formula right here, delta x is equal to xf minus x0. that is the final position minus the initial position. So if the person goes from point 0 to point 3 back to point 0, then its displacement would be 0 because the initial position and the final position is both 0. So 0 minus 0 is 0. So then it'd be the displacement would be 0, but that's different from the distance traveled. As for the distance traveled, that's the total distance the person travels, right? So from 0 to 3, that's 3, and then from 3 to 0, that's another 3, right? So then it'd be 6, and then also it's important to remember the units, right? Because so for position and displacement, the SI unit would be meters, right? Meters. So yeah, that's also important to remember. Okay, and then so then velocity, right? Velocity is not the same thing as speed because velocity is a vector, but speed is a scalar, right? Velocity has a direction, right? So then velocity, what velocity is the displacement over a period of time, right? This formula right here, that's average velocity is equal to delta x, which is the change in position over delta t, which is the change in time, right? So then the SI unit for velocity is meters per second. So m over s, meters per second. Right? So then for acceleration, acceleration is the rate at which the velocity of an object changes. So that'd be change of velocity over change in time. So then that's velocity final minus velocity initial over how long it takes, right? So then for AP Physics 1, it's important to remember that all the questions you'll be dealing with should be constant acceleration. And so you don't have to worry about like the acceleration like changing all the time. And then the SI unit for acceleration is meters per second squared. So it's like meters per second squared. So then these are the five kinematic equations. Yeah, so I believe 3 of these are on the AP Physics 1 formula sheet. So this one is on the formula sheet. This one's on the formula sheet. And hold on. No, I'm sorry. This one's not on the formula sheet. So this one's on the formula sheet. This one's on the formula sheet. And this one should be on the formula sheet, I think. So then basically what these equations are, so this one is so x is equal to x0 plus vt. That's basically finding the position, right? So you want to find the position of an object after, so like say we have an object right here, right? And then it's at position 0, right? And then 1, 2. And then we're told that it's moving at a velocity of 3 meters per second, and then it moves for 1 second, right? So then we'd use this equation to find its final position. X is equal to x0, which is its initial position, which is 0, plus v, the velocity we're given, which is 3, times t, which is 1 second. So then its final position would be at 3. So then the second equation is for average velocity is just initial velocity plus the final velocity divided by 2. That's for average velocity. And then the third equation is to find the velocity after a certain amount of time. It's very similar to the first one because velocity is just, acceleration is just change of velocity over time. So like you take the initial velocity. So like we have a rock, right? And it's currently moving at 3 meters per second this way. And then we're told that the acceleration is 4 meters per second squared. So then that would mean that for every second the rock is gaining 4 meters per second. It's becoming faster, right? So then if we wanted to find the velocity after 5 seconds, for example, we take the initial velocity and then we add it to the acceleration times the time. And then that would be equal to 23 meters per second. And then the fourth equation is to find the distance an object travels, right? If you're given the initial position, initial velocity, time, and acceleration. So like say there's a object, right? And then basically we're told that it moves at 2 meters per second. And then it starts off at 2 meters per second at position 0, right? At the origin or whatever. And then the acceleration is 4 meters per second squared. So then let's say after 2 seconds, right, we want to find how far it's traveled. So then we'd use this fourth equation, right? So then x is equal to its initial position, which is 0, plus its initial velocity times the time plus 1/2 of its acceleration times time squared. So then you would get 4 plus 8, and then you'd get 12 meters. Okay, and then for the fifth equation, use the fifth equation for when you don't have time, like when you're not given time. So like each of the equations, they kind of have like one variable missing. So you have to figure out which equation you want to use depending on what you're given in the question, right? So you'd use the last equation if you aren't told anything about like time, but if you are told it's like initial and final velocity and the acceleration, then you use it to find like the distance, right? So like for example, let's say your initial, so if the I indicates the initial velocity, right? So your initial velocity, you're moving at 3 meters per second. And then let's say you're accelerating at 4 meters per second squared, right? So then and you move from point A to point B, right? And then the distance is, let's say, 10 meters, right? So then if you want to find the velocity of the ball when it gets to point B, then you would use this last equation, right? So the velocity squared is equal to 3 squared plus 2 times acceleration times the distance, right? So then you just you could plug it into a calculator or something, because the equation the numbers aren't exactly round, I don't think. So yeah, it's important to know that for these equations, there's acceleration in the equations, right? But these equations only work if acceleration is constant. So like either acceleration is equal to 0, right? It's moving at a constant speed, or the acceleration is constant. These equations won't work if the acceleration is changing. But you shouldn't have to worry about that for physics 1, because they usually won't give you questions that with changing accelerations. But if any of y'all plan on like taking physics C, then eventually y'all will have to learn how to do kinematics with changing acceleration. Okay, so I guess I'll give a few example problems now. Does this all make sense? Does anyone have any questions? Like, or like, am I going too fast? Okay, so I guess I'll give an example. So let's say this person, right? He wants to walk this way, right? At a velocity of 3 meters per second, right? And then let's say for 5 seconds, right? So then what would be the total displacement, or like how far would he go? Y'all can just type in the chat if you want. Okay, yeah, I still have you say 15. That's right. So it was just that equation, velocity, uh, well, technically, it's the full equation would be velocity times time plus 1/2 acceleration times t squared. But usually, if they don't give you an acceleration in physics one, that just means there's no acceleration. So then, if there's no acceleration, you can ignore this, right? So then the simplified equation would be just velocity times time, which is 3 times 5, which is 15. Okay. Oh, okay. First, let me talk about graphs. So in physics one, there's going to be a lot of graphs. So it's important to know how to read a graph. So x represents position displacement, right? And then t is time. So this would be a position versus time graph, right? And then let's just say it was like, so then it's important to know for a position time graph, the slope of the position time graph would be equal to the velocity, because velocity is change in position over change in time, right? So like if we want to find the velocity at this time right here, we'd find the slope right here. And then since this is physics one, you just find the average velocity because you haven't learned calculus, right? So then you don't have to take like the derivative or anything. So you would just take this point right here. Yeah, assume this is a straight line. But yeah, you take this point right here, this point right here, and then you let's say this is like 5, this is 0, this is like 2, 3, 4, right? So then you do change in position. So initially it's at 5, right? And then it ends up at 0. So 0 minus 5 equals 4 minus 2. Because so then, yeah, your velocity would be negative 2.5 meters because uh, you're going from the position 5 to the position 0, and it takes 2 seconds. So then, yeah, the slope of a position time graph is equal to velocity. Now then, for a velocity time graph, it's kind of like the same thing. The acceleration is equal to the slope of a velocity time graph, because acceleration, once again, is equal to change in velocity over change in time. So you would do the same thing, really. So then the slope of this line right here, that'd be the acceleration of the object during this time period. And then for this part right here, if a velocity time graph is flat with a slope of 0, that means the object's not accelerating, and that means there's a constant velocity. But then it's important to remember that even though the velocity time graph is flat, right? The acceleration is 0. That doesn't mean that the object is not moving, because like that tends to be like a kind of trick question on the AP test, right? They'll like, for example, like they'll try to trick you and like get you to say that an object's not moving when in reality it's moving, right? So like say an object's moving at 3 meters per second, and then but then they give you a velocity time graph that has a slope of 0, then what happens is the object continues to move at 3 meters per second. It'll stay moving at 3 meters per second, right? So then over time, it's actually moving, right? So like over 5 seconds, it's actually moved 15 meters. But you might fall for the trick and think, oh, it hasn't moved at all because it's not accelerating. You look at the graph and then the slope is 0. You think it's not accelerating, but no, it's actually moved a lot. It's just this the velocity itself is not changing. So then so that was mainly like for 1D kinematics. So for 2 dimension, I guess that's just like X, Y, right? It can move in 2 directions. Like say we have something at the origin, and it can, for example, like the velocity could be this way, right? So then for 2D kinematics, you can use the kinematic equations still. It's just you're gonna have to do them in both directions, right? So like say there's a object right here, and it's going in the y direction, it's going at 5 meters per second, but then in the x direction, it's going at 12 meters per second, right? So then its velocity, you'd have to do like the Pythagorean theorem. So it's so like its velocity would be 13 meters per second because you do the Pythagorean theorem. What is it? Like 5 squared plus 12 squared is equal to 13, right? So then a lot of times for the kinematic equations, you'll see like a Vx or a Vy. So the X would indicate like the velocity of an object in the X direction or the velocity of an object in the Y direction. And then another thing to parabolic trajectory. Usually for okay, so for parabolic trajectory like free fall, the first thing you need to know is gravity. The acceleration caused by gravity is equal to 9.8 meters per second squared. But I'm pretty sure for AP Physics 1, on the AP test, you're allowed to just assume gravity is equal to 10. So like you have better numbers, like easier numbers, like you don't have to have all that many decimals. But usually in free fall, you break a problem down into the X and Y direction. I don't think people usually use the quadratic equation because it's simpler to break it down into the X direction, in the X and Y direction, right? So like, for example, like there's a cliff right here and there's a rock, right? And then we push it off at 3 meters per second. Let's say the cliff is like 20 meters tall, right? So then let's say we want to find how far it goes, like where is this point, right? How far from the bottom of the cliff. So then first, we can't put find the answer in one step because we don't know how long it's in the air for, right? So we know the velocity initially is 3 meters per second. And then we know we don't know time. And then and then acceleration in the x direction is always 0 in terms of free fall, because like gravity is always downwards, right? Gravity's always trying to bring you down. So then like you would split this into 2 parts. So first you would find the time, right? So then so y and x, y also stands for displacement, but like I'll be using y because like that's like the vertical displacement. So like delta y is equal to VIT plus 1/2 AT squared, right? So then first we'd use this equation in the vertical direction. So it drops 20 meters, right? So that means is -20 for the displacement. And then initially in the y direction, it's not moving because the rock is moving 3 meters per second outwards, right? It's not going down. And then time, we don't have time yet. We're still solving for time. And then 1/2 So then, like I said, acceleration is 9.8, or you can just assume it's 10 for the AP test, right? And then t squared. So then this is 0. So then we would solve for t, right? So then t, oh, yeah, acceleration is negative because it's gravity and it's bringing you down. So acceleration is negative. So then this would be 20 times 2 divided by 10. That's I believe 2 seconds. So then basically what this tells us is it takes 2 seconds from the rock to get from this point to the ground. Oh, it's 4. Uh is it? Oh, okay. My fault. So then T would be 4. Wait, are you sure? Because oh yeah, sorry about that. It's T squared, guys. So it would be negative 20 equals 1/2 times negative 10 T squared. So then you multiply by 2 on both sides, and then you divide by negative 10 on both sides. Oh, sorry guys, it's like kind of messy, but yeah, so you get T squared equals 4, so then T is equal to 2. So yeah, that sorry about that. Yeah, so basically what we just saw for is the time it takes for the rock to hit the ground, right? So then we want to find how far it goes, like the distance it travels, right? So then we go in the x direction, right? So then we use the same equation, delta x is equal to vi. Oh no. Okay. Okay. Delta x is equal to v t plus 1/2 a t squared. All right. So then we're solving for delta x. We know the initial velocity in the x direction is 3, right? And then we just solve for the time. It's 2 plus 1/2. And then acceleration in the x direction is 0 because gravity is only in the y direction. And then t is 2, right? So 0, we can ignore that because it ends up as 0. So then we find the distance the rock traveled horizontally would be 6 meters, right? So then we didn't really use, so like I know someone had a question about the quadratic equation. We didn't really have to use it here, but I guess in some instances you would, but like not necessarily for finding the velocity, but it'd be like right here, like because there's a t squared, right? So sometimes you might have to use the quadratic equation for that. But yeah, when finding like the velocity of an object, like I said, like earlier, it's just the Pythagorean theorem for that. Okay. I guess I'll give you an example problem. Okay, so uh, okay. So let's say um yeah, I'll just write it out. Actually, I'll just type it out because it's faster. Hold on. So we have a body moving in the x direction, right? And then it passes the origin at t equals 0. And then between t equals 0 and t equals 1, we know that the object is moving at a constant speed of 24 meters per second. So then at t equals 1 second, we're told that the body is given an acceleration of 6 meters per second squared. And then this is in the negative x direction. So then we want to find the position x of the body at 11 seconds, at t equals 11 seconds. Can y'all see the question or? Okay, I've seen a few of you put negative 36 in the chat, I think. Okay, I'll explain it now. So then basically we're told that velocity is equal to 24 meters per second initially, right? And then acceleration is negative 6 meters per second squared. And then at time 0, it's at the origin, right? So it's delta x, or x is equal to 0, x initial, right? So then we just use the equation delta x is equal to v t plus 1/2 at squared, right? So initially the velocity is 24, and then we're doing this for 11 seconds, or yeah, 11 seconds. And then negative 6 is the acceleration, and then time is 11, right? So then well, 1 second. Yeah, make sure you remember the accelerations in the negative x direction. And then wait, hold on. I think I might be doing something wrong. Hold on. Because oh yeah, my fault. So t is not 11. T is 10. I'm sorry about that. Because the acceleration starts when t equals 1. So then t is equal to 10. So then it'd be 24 times 11 plus 1/2 times -6 times 10 squared, right? And then the answer you should get, it should be negative negative 36. It should be, yeah. Sorry about that. Okay, I'll do another question. Okay. Yeah. I'll give you some answer choices, I guess. A would be D. Okay, so try this for a few seconds, for a bit. Okay, I guess I'll explain it now. So there's a diver, right? It's moving horizontally on a cliff, right? With a velocity or a speed of v, and then they end up landing at a distance d away, right? So then what we're changing is we're gonna be making the initial speed 2v, right? So then remember when we did the example projectile question earlier, uh when we like wrote out all the stuff for delta y equals v yt plus 1/2 at squared, right? Um we did this to solve for time, right? And then from there we plugged into the other equation. But one thing we can see is all that's changing is the horizontal speed. Yeah, so you can think about it, you can just think about it logically. You don't have to actually like solve with numbers. So all we're changing is the horizontal speed. So that doesn't have effect an effect on the vertical direction. And since we use the vertical direction to solve for time, and that doesn't change, the time the diver's moving is still the same, right? So then for the x direction, delta x is equal to vt. Since there's no acceleration in the x direction, since the time is the same and the speed is doubled, then the distance would be doubled. So then the answer would be C, 2D. Okay. Also, I wanted to say one more thing. So for projectile motion, let's say there's like a cannon and you fire a ball and it goes in a projectile motion. At the top, like at the most highest point it reaches, right here, the vertical velocity, Vy, will always be 0. But it's important to remember the acceleration will always be g, or 9.8 or 10, however you want to do it, right? Whatever you're using for g. So like on the AP test, another common question is they always ask for the acceleration of an object at its highest point in a projectile motion. So the acceleration is always 9.8, but the velocity is always going to be 0 because you see, when it's going upwards, the velocity is going to be positive, and then when it's going downwards, since you're going down, the velocity is negative, right? So then, right in the middle, like right when it's at its highest point, right? That's when it's in the middle. The vertical velocity is going to be 0. Yeah, it's negative 9.8. But like, yeah, my fault. But like, yeah, since acceleration is downward. But sometimes people just do g is equal to 9.8, right? So then when they do like one of these problems, right, where it's going down a cliff, right? Sometimes people just use g as 9.8, and then for the displacement, they make it a positive number instead, right? So it's just you have to make sure that it's relative, right? So either you're going to have one side be the positive direction, one side be the negative direction, right? So if there's a cliff, right, and you're pushing it off, you can put g as 9.8 in your equation as long as you make sure that your delta x is positive. But if you want to make it negative, then they both have to be negative. So as long as it matches up, you'll still get the same answer because the negative signs will cancel out. Yeah. And then so like in a projectile motion, the only velocity at the top of the point would be in the x direction, right? Whatever the initial x velocity is, it shoots out of the cannon at, it stays constant because there's no acceleration in the x direction. So then here's another question, I guess. Yeah.
down to D one does not say anything about how annoying getting to the decision letter was. However, the encore.
Okay, so for this question, the answer to this question is probably best if you like memorize this for the AP exam, because it's like a common question. So basically, the answer is D, 45 degrees, because when you throw an object, when you throw an object, right? It's a parabolic motion, right? So then, how far it travels, it depends on both the initial horizontal speed and the time the ball's in the air, right? So then, what's it called? So like, if you throw it at a greater angle, right? If if you throw it at a greater angle, the ball will be in the air for longer because the initial y velocity will be higher, right? Um, so then that means it'll take longer for the acceleration to bring it down, right? The for gravity's acceleration to bring it downwards, right? So that would mean the ball would be in the air for longer, right? So that increases t, but that means that the initial um, x velocity would be smaller, right? Um, so then for displacement, right? That would mean v vx times t, right? So then if the angle is bigger, then this decreases and this increases, right? And then for if you make the angle smaller though, that increases this, right? But it decreases the time because your initial y velocity is lower, right? So then 45 is like the sweet spot basically. It's the perfect middle, right? So it maximizes your how fast you're going initially in the x direction, and it also gives you the best time, right? So yeah, the answer would be D, 45 degrees. So this one, it'd be best to just memorize this and to know that 45 degrees gets it the furthest, right? And yeah, so it's kind of like um I guess an analogy for it would be like kind of like how for example, uh let's say you have two numbers, right? That add up to 8, right? So then 3 times 5 would be 15, right? But then 4 times 4 would be bigger, 16, right? So like here we're decreasing one number, we're increasing the other, right? And then you get a multiplication, right? And then if you bring it more towards the middle, the final value would be bigger, right? So 4 times 4 is greater than 3 times 5. So like kind of like for this, yeah, like someone said in the chat, it's the middle is the sweet spot basically. So you 45 degrees is in between 0 and 90 degrees, right? Straight up and straight out, right? So then that's the sweet spot where basically it maximizes the time you're in the air and the initial speed it goes out at. So then therefore it goes the furthest distance. So yeah, it's important to remember this for the AP test. Okay, and then here, I'll just draw the next one. Okay, just assume that's a straight line. Okay, so then say you're given this graph, right? So then what would be the velocity at t equals at the time of 3, right? Velocity at t equals 3. So you can just put it in the chat. Okay, so basically, you're given this position versus time graph, and you just want to find the velocity of the object at time equals 3. Okay, so yeah, since it's a straight line, right? And velocity is change in position over change in time. So it's just a slope, right? So then all we have to do is just find the slope of the line, right? So then we just do let's say we take these 2 points. Yeah, it would just be the derivative or the slope if you haven't learned calculus yet. So yeah, it'd just be 0 minus 2 over 3 minus 0. So negative 2/3 meters per second. Okay, I wanted to go over one more thing real quick for the graphs. It's like for a position time graph, or no, for velocity time graph. Let's say we wanted to find the distance, right? So like say this is 2. So say we wanted to find like the total displacement. You could break this down into like a bunch of problems, right? So for here, you find the acceleration of it, and then you use the kinematic equations, right? And then for here, it's constant acceleration. So you just do velocity times time, and then you do the kinematic equation for this one again. But since it's a velocity versus time graph, right? The units of velocity are meters per second, and the units for time is seconds. So actually, if you want to find the displacement, you can just find the area under the curve, right? Because meters per second times second would be equal to meters, which is the unit of displacement. So like instead of breaking it down into a bunch of kinematics problems, you can just find the area under the curve, right? So then like when there's positive and negative, what you do is find the area of this trapezoid first and then subtract it from the area of this, and that'd be the total displacement. Someone asked me if for a position versus time graph, is acceleration the area under curve or the double derivative? So it would be the double derivative, I believe, because yeah, second derivative, because yeah, it wouldn't make sense for, because if you can just look at the units if you're having trouble remembering whether it's slope or whether it's area under the curve, because if you do area under the curve, you're multiplying them, right? So meters times second, that's not the unit of acceleration, so it'd be the second derivative, because you take the first derivative and you get velocity, and you take it again and you get acceleration. So yeah, if you wanted to find the total displacement in this object, you just do what's it called? You just find the area of this trapezoid, right? So this is 6. This is 9. So 6 plus 9 by 2 times 4. That's 30, I believe. And then the area of this small triangle right here. Oh, I never gave it a negative velocity. Okay. So then the area of this small triangle right here would be negative 4 times 1 divided by 2, which is negative 2. So then you just subtract the area of the small triangle from the trapezoid, and then so then the displacement would just be 28. So yeah, yeah, basically yeah, for the area under the curve for a velocity time graph is just how the displacement of an object. So yeah, that's a good trick to use on the AP test, so you don't have to plug in the kinematic equations multiple times. If a problem asks for distance, it would be the same thing. Yeah. So if a problem asks for distance, you would also do area under the curve. Instead of subtracting it though, you would just add the two areas together, right? Because you just do the total distance traveled, right? So you it's like the absolute value, right? So you just take you make the negative area positive and you just add them together. So for this question, it just be 30 plus 2 instead of 30 minus 2, and you get 32. Yeah, that was a good question. Okay. It's 6:02, I guess. So I guess that's it for the first meeting. So yeah, see y'all on Saturday, I guess. Yeah, and then as for homework, I'll post it on Google Classroom later today. So then yeah, y'all can do the homework. And yes, there will be meetings of this on YouTube. So don't worry if you like miss part of class, or like you're not able to come to class today. They will post the recordings on yeah, on YouTube. Okay, bye everyone. Yeah, y'all are free to leave.